right, Noah. Good job. All right, power functions. We're going to look at negative exponents, positive exponents. We'll stick with positive first. A power function is just a monomial function that is one term. And it may look something like that's a power function. Okay. We do know this type. This is a polynomial. What is the close? What's it look like when you graph it? It does for these. So normally, if we exaggerate the humps, if we stretch it and shrink it just right, it'll come out doing something like this. For this one, it's probably, in fact, if you graph this on your calculator, 3x to the fourth. You will notice when you graph this that the humps are not pronounced. Okay, so it really looks more like, it kind of looks like this, and it kind of almost bottoms out here on the back. But that's because as you exaggerate those humps, but it really looks like a quadratic is what it looks like. Okay. We're not going to focus on a whole lot of graphing by hand. Well, we are, but we're not. It's going to be more sketching and analyzing. I lied about what? Let's talk about symmetry. What did I tell a story about? Yeah. If the power of the monomial function is even, then the symmetry is also even. That's exactly right. If the power's odd, my symmetry is odd. And remember what that means. If I have even symmetry, that means I'm symmetrical about what? The y-axis. And if I'm odd symmetry, turn it upside down, it looks the same, right? Sometimes we call that rotational. Let's get into an example before I show you the new stuff, which is the negative exponent one. Look at that. Origin is rotational. Ready? Let's say I asked you to graph this. Negative 1/2 x to the, let's go to 6. I was going to do 4, but let's go. Now it's a quintic. That's exactly right. It's a quintic. What does the symmetry look like on this one before I even graph it? It's odd. Okay? Easy, easy, easy. Yes? If that exponent is even, it's even symmetry. If that exponent is odd, it's odd symmetry. If I want to graph this, what I really want to do is pick up a couple of points to pick up the pattern here. So maybe I know what this is going to look like, right? Or do you know what this is going to look like? It has 5. What are the ends going to do? Same or different? Different. Am I going up to the right or down to the right? Ooh, I heard both. Down to the right because it's been flipped, because it's negative, right? So it's going to do something like this. But depending on the humps that I have, for these power functions, though, they're going to look more like that cubic or quadratic is what they're going to do. So let's graph a couple points. Let's see what it looks like. You can use your calculator also. Do y'all know how to go into the table for your calculator? You really don't? Ooh, y'all, I can't hold. Take that. Okay, we'll go turn it off. You know. This was for you today, Kate. All for you. All right, I'm gonna go y equals negative 1/2 x to the, what I say, 5. Remember, if you put a fraction in here, make sure you do it in parentheses. And hit zoom 6 will give you a standard window. That's what your graph should look like. Notice it's looking like a cubic, right? Even though it's not. It's flattening out there on that axis. But to pick up a couple points, if you go second graph, it'll pull up your table. You should be able to type some values in there. No, you can't. Huh?
On the last step?
Okay, no, don't use trace. Don't use trace, because watch what happens whenever I trace. I get all these nasty decimals. Second trace. Oops, no, you don't want to do that. You don't want to do that. You want to go to table, second graph. What did you go to? Value? No, you can if you want to. If you want to do that. It's just more work. Then you have to do that every single time. But if I go second graph, I can pull up that whole list. So maybe I want -2, -1, 0, 1, and 2. And I've got a whole list of numbers just that quick that I can plot and graph. Will yours let you type it in or no? Okay. If you're having trouble and it won't let you type it in, go second window. And you should have, it should say ask and then auto. So make sure that that's highlighted to ask and then auto. And then go back second graph. Once it's set, it's set. Yes, you just type them in. So just hit -2, enter, -3, enter, whatever you want. Second graph. And it should just let you type those values in there. Does it? Okay, you might already have, it might already be set up for that. Second window. Oh, that's fine. And you can just, that's fine. If you got what you need. If there comes a time when you need to put a specific value in there and it's not showing, you would have to change this over from auto to ask so that you could type whatever you want. I just like to keep it on ask so that I don't have to scroll through the numbers. I can just put what I want in there. But yes, you could have been doing that all along. Absolutely. I should quit playing that game. Because he's not staring at my podium.
What number?
Say that again. So I kind of graph it and look at it. I see what it looks like. So I pick up enough that I could graph that on my paper and I could pick up the pattern. So I might, even for this one, I might just do -1, 0, and 1 and know what those look like. So -1 should give me what? 0.5. 0 gives me 0. 1 gives me -0.5. And I know, I mean, I can really kind of see what this is doing. And I'm okay with that. Our big thing right now is going to be the analysis that goes along with it. Huh? Analyze. What's that? Analyze. What's the domain? Oh, no, we never stop analyzing. What's the range? How about x-intercept? What if I couldn't see that? Plug in what? A 0 for y. That's right.
A 0 for y.
Okay, what about the y-intercept?
0 for
Yes. 0, 4. Oh, no.
Well, I was switching that to last.
You were. You literally just turned it in. And you didn't know it then, but you know it now?
Well, yeah, it's like
To find the x-intercept, you put a 0 for y. If I couldn't see it and didn't know what it was, if I needed to find algebraically the x-intercept, I'd plug in a 0 for y and solve it. And then the y-intercept, a 0 for x. And solve it. Right, as we get into transformations. Correct. That means if I had an equation and I looked at my graph and I couldn't tell where it crossed the x-axis. So I could take my equation and I could set y equal to 0 and solve it for x and it'd tell me where it hit. Because it might be that it hits all the way at like 572 or something. All right, increasing intervals. Done. How about decreasing? Always. Negative infinity. How about, we said symmetry, discontinuities? None. Are any of these going to have discontinuities? No, I'm fixing to show you some that do, though. How about in behavior? That's right. So now let's look at the new stuff. Ready? 2. Did she really? How did your tutoring session go? Yeah. Oh, good. All right, let's look at power functions with negative exponents and what happens. No, that's fractions. It's fractions, that's right. So let's think about if I had something like x to the negative 2. That's really the same thing as what? 1 over x squared. Exactly. So now I do get into some problem areas because what do I have here? What's on my graph for this one? Starts with an A. An asymptote. Why do I have an asymptote on this one? I can't ever be 0, right? And that's what I'm going to run into with every one of my negative exponents is I can't be 0. That's going to give me a vertical asymptote at x equals 0. Okay. So here's what I'm going to have you do. When you graph these, the first thing you're going to do if the exponent is negative is identify the vertical asymptote. Now, for the first day, they're all going to be x equals 0. They're all going to be a vertical asymptote on the y-axis. We'll start moving them tomorrow and later, but for right now, they're all just x equals 0. And then when you plot your points, I want you to do 2 points at least. So we're going to say greater than or equal to 2 points on either side of the asymptote. At least 2 points on either side of the asymptote. Okay, I'll show you. You just try to know what to. Because he's watching you play that little game. All right. Here's what I want you to do. Check out your calculator again for a second. I told you we're going to do a lot of this on the calculator. Let's see what happens when we force these exponents to be negative. Go y equals, and let's just do x to the negative 2. Let's just start with a negative 2. Take a look at that graph and see what it looks like. When you square a number, it makes everything positive. I'm always above, but that's still an asymptote right there. It is kind of like a reciprocal, but the reciprocals you did were x, y, and then they had the little wings off to the side. Does it? So y equals, and change it to a 3. So we've got x to the negative 3rd. And see what happens. Now this looks a little more like that reciprocal function, right? See what's happening with them? What happens if I had to the 4th, but let's put a negative in front? Okay. I'm basically looking at 2 different situations here. Situation 1 is what you're used to, which looks something like this. Okay? These are my odd negatives. Now, if I flip that and make it negative, all it does is change where these little wings are happening, right? That would be a negative leading coefficient that reflects it. If I am even, and this is a negative exponent, not a negative inference. If I'm an even but a negative exponent, even and negative exponent, I still got that asymptote right here. But this time, I'm doing this. That negative piece is flipped up. Then, of course, I could flip it upside down. So those are my 2 main scenarios that I'm looking at as I do these, okay? Let me run through one with you. No, nobody likes these. You would. Let me run through an analysis with you. Actually, let's just look at the one that I have on here so that it takes a little. Domain. What's the domain? That's exactly right. I'm going to write this little analysis right here beside it. This is y equals negative x to the negative 4. So we said negative infinity to what? 0 to 0 to infinity. Right? How about the range? X-intercept. There isn't any, right? You see that? There's this asymptote here. It's hugging. It's never coming through and crossing. It's getting closer and closer, but it's never actually crossing over. This y is always staying negative. It's never turning positive. So none. How about a y-intercept? None again, right? Increasing intervals. None.
Wait, there is.
Oh, there is. You're right. Look, I'm going down, down, down. Here I'm going up, up, up. Close. 0 to infinity. There you go. Decreasing is negative infinity to 0. How about symmetry? Even, look at that exponent, right? Discontinuities. Where? Infinite at 0. Asymptotes infinite. Okay, go, Miguel. Yep. 0 from, yep. Approaches negative infinity. Uh-huh. There you go. Good. Good. This is actually, when we get to calculus, this is the definition of a horizontal asymptote, and this is the definition of a vertical asymptote. That's how we can prove that it is or it is not. What? Zero? Yes, yes, that's what it means. This says, because if you look, I'm approaching 0 from this side and from this side. And they could be going in different directions, so I have to address both of those. So I say 0 from the left, so that means from the left is this way. So as I come in this way, what's my graph doing? It's negative infinity. And then this one is from the right side, so as I come in from the right, it's also going.